Hi guys, this is EasyElimu channel. I'm Vincent Kanamwai. I'll be taking you through Form 3 mathematical work, and today I'm going to start with the quadratic expression and equation 2. Stay tuned as I welcome you all. In Book 2 of Form 2 work, we learned how to factorize different kinds of quadratic expressions. And today we are going to factorize them further and identify which kind of factors are they formed after factorization. For instance, we are going to factorize quadratic expression here, and we shall, for instance, start with an equation of x squared plus 6x plus 9. And here, having this expression, we learned how to factorize them in Book 2, and we did say that in order to factorize this, we can use simple ways such that, for instance, we know any kind of quadratic expression is given in ax squared plus bx plus c. And if we view this, our quadratic expression here, we shall find that our ax here, if we compare the coefficients, whereby this a, b, and c, we say a, b, and c are all constants. They are given constants, but x is the only variable here which depends on this constant. So we can factorize here by relating the two equations, and we can say that if we relate the two equations and relate the coefficients of the two equations, we shall find that for the coefficient of x squared in this expression is 1, because a here is simplified by 1. And for bx here, we can say the coefficient of x is 6 and c is represented by 9. So we can say that our a here is 1, b is equal to 6, and c is 9. From there, we can factorize this equation by, we say you can use different kind of factorization. For instance, for this one, we can say two numbers, whereby if you find the sum of the product of those two numbers, and let that product be represented by letter P, if we find the product of the two numbers, you will find that you will take A, you multiply by C, it should give you 9 multiplied by 1, you get positive 9. And if you find the sum of those two numbers, and sum here, I'm taking my sum to be represented by S. If I take the sum of those two identified numbers, I will get the value of B. And for here, my value of B, I'm getting it to be positive 6. The same to the value of the product, I get in 9. So we needed to identify those two numbers, whereby if you multiply the two numbers, you get 9. And if you do the sum of those two numbers, you get 6. And if we may identify, you will find the two numbers is 3 and 3. So we have identified the two numbers, and we have obtained is 3 and also 3. So we are going to factorize this equation with the two numbers inclusive, whereby where we have this bx, which is now positive 6x, we shall replace it with the two numbers having the variable x. For instance, I will now rewrite that equation in form of x squared plus now one of the number, but we identified the two numbers are all positive. So I will write with 3 with the present of x plus another 3 here with the present of x, then I add 9. That one, the whole equation remains the same, but what changes only is the bx. And here, I haven't changed anything. It's only if you take 3x plus 3x, you will still find 6x. But here we need to factorize. So what you will do, now you factorize by taking two sides and a common factor between them. For instance, for the first here, we may decide. You will take, for example, here the common factor between the two numbers we are going to find is x. And if you factorize x here, you are going to get that x squared divided by x, you will find you will get x. And then for this instant 3x, you are going to get positive 3. And for the other, the common factor between 3x and 9, we are going to get is 3. So it shall be positive 3. And because we have said this is the common factor, then the others we shall put them in brackets such that if you take 3 into 3x, we are going to get x. 3 into 9, you will get 3. And if you expand this expression here, it is going to give you back to this expression, which is the same as this expression here. So after doing this, we are finding that this function or factor which is in bracket here is the same as this one. So what we shall do is only to take the ones which are outside, we put them together, and then we choose one from inside the bracket. For instance, we shall take x, we add it to 3, then we close the bracket, and take one of the common factors here, which is x plus 3. If you expand this expression, it will give you back this expression. And after getting this, we can identify from this expression that this factor which is in the first bracket is the same as the other in the second bracket. So we can rewrite this factor as x plus 3 but squared. We have factorized this expression here, and we have found if we factorize this x squared plus 6x plus 9, we shall get this. I remember how to find the product and the sum. The two numbers can be found in the way you want, and you will find after factorizing you get that one. This is another expression, and we need to factor. This is another expression we need to factor is the same as the other one, and we can still identify it's still having the form ax squared plus bx plus c, whereby our a is 1 and our b is also positive 1 and our c is negative 12. So we need to factor this expression, and we can say that if we want to factor out using the same procedure which I gave you, you will identify that if you find the product of two numbers, in that if you take a, you multiply by c, it's going to give us negative 12 multiplied by 1, you will get negative 12. If you find the sum of the two numbers, it will give you the value of b, and for our case here, the value of b is positive 1. We have to identify two numbers in which, if we multiply those two numbers, we are going to get negative 12. And if we find the sum of those two numbers, we are going to get positive 1. And if you may identify them clearly and much more easily, you will find you have positive 4 and also you have negative 3. If you take positive 4, you add it to negative 3, you are going to get positive 1, which is here. But if you take positive 4, you multiply by negative 3, it is going to give you negative 12. For that instant, now we have identified the two numbers, and we shall say we are going to rewrite this equation with bx being replaced by the two numbers having the same variable x. For instance, now I will rewrite that equation here down and rewrite it as x squared plus, where there is b, bx, now I'm going to replace the value of bx with here, and we shall start with the 4, and I will put it is positive 4, now with the variable x, then this one is negative 3 with the variable x, because this one is now representing the value of b, bx. So I just replace, and if you do this, you are going to get the same thing up there. And then you write negative 12 to complete the equation or the expression as it was. So after completing that way, now we can factor out by factoring out the common factor between the two chosen items. For example, for the first one, I may choose x is common between x squared plus 4x for the first two items. And then if I factor for x squared, I'm going to get, if I factor here x, it will go into x squared x times. Then in 4x, I'll get, it will go there, positive 4. And I will put that one in bracket. And then I'm going to the second two items and factor out. For instance, here we may find in negative 3x minus 12, I'm going to find a common factor is negative 3. Thus, if I factor out with a common factor which is negative 3, I'm going to get negative 3 into negative 3x, I'm going to get, it will go there x times. Then, if you take negative 12 divided by negative 3 here, you are going to get positive 4. Because if you take a negative, you divide by a negative, you will get your answer to be a positive. And here we can identify that the factors which are in the bracket are the same. Thus, we can take the outside factors and say that x minus the outside factors, we put them together, and then after factorizing them or putting them together into one bracket, we shall choose one of the factors in the other bracket, and we shall put x plus 4. If you expand this expression here, it will still give you back your expression. Remember, this one we are getting is x minus 3, and this one is x plus 4. The factors in the two brackets are not the same. Thus, we are obtaining something of x minus 3, and the other one is x plus 4. But remember the previous one, we had x plus 3 and x plus 3, which gave us x plus 3 squared. The previous expression. We identified that the previous expression gave us factors, two factors, but which were identical. But this one, this expression here is giving us two different factors. We have two factors, but each in each bracket having different, being different from each other. For instance, here is x minus 3, this is x plus 4. Thus, we have identified those factors. We can conclude by saying that those factors which give two identical factors, we call them perfect factors. For instance, this x plus 3 is a perfect factor. So the first expression was giving us a perfect factor. And then this one is now the other, is not a perfect factor. So if you factorize any kind of a quadratic expression, in general, if you factor out any kind of quadratic expression and you find out that it is giving you two identical factors, like this ours here, then you know that it has given you a perfect square or factor. But if it doesn't, for instance, this expression gave us x minus 3, x plus 4, which are not identical, then it is not a perfect factor or perfect square. We are going to see how we can complete the square, and here completing the square is a method which are used to make all quadratic expressions which are not perfect to a perfect square. For instance, we are going to see how a quadratic equation of any kind can be made a square by completing its square. For instance, let's say we have x squared plus 10x. Being given this kind of quadratic expression, we can complete the square of whereby it has to be, let's just give it ax squared plus bx plus c, whereby a, b, and c are constants, and x is the variable which here we are dealing with. For instance, here we have x squared plus 10x, but we don't have the value of c. We can complete the square, and if you identify very well, for any kind of given quadratic expression, for example, having another one like x squared plus 6x plus 9, and another one, for instance, x squared, no, let's just use this one, it will give us what? So having kind of this one, we can identify from this kind of quadratic expression and any kind of given quadratic expression which has perfect square, you will identify that in order to find this value of C, it's like getting the value of B, then you divide by 2 and you square it. If you take the value of B, you divide it by 2 and you square the result, you will find this value of C. And if this A here is not 1, A is not equal to 1, meaning A is greater than 1, then to find the value of C, you will take B, actually you will take A multiplied by that C, then it will be equal to B over 2 squared. If you take the coefficient A, you multiply by C, you will get the coefficient B divided by 2 squared. That is for the case where A is not equal to 1 and not equal to 0. But for our quadratic expression here, where A is equal to 1, we are using a quadratic expression where A is equal to 1 and not equal to 0. For this quadratic expression here, we shall identify that to get the value of C, we shall take B over 2 U squared. And if you do that, for instance, for this one, you are going to get, for example, 6 over 2, because here 6 is our B, over 2, then U square, you are going to get 6 divided by 2 is going to give you 3. If you square 3, you are going to get 9. I say here will give you 3 squared, and then you are going to get it 9. And this is our value of C, which is here present. The same can be applied to our quadratic expression here, and we shall find that if we want to complete the square ax squared plus 10x plus c, if we want to find this value of c, we shall take c is equal to b over 2, then we square. And here our value of b here, we can identify the value of b to be 10, because b, coefficient b is represented here by the value 10. So we shall take 10, we divide by 2, then we square. And if we do that, we are going to get here the value of c is being, here if you do, you are going to get 5. 10 divided by 2 is going to give you 5. And if you square 5, you are going to get 25. Now we can complete our quadratic expression here and say that the value of c, we can give it gladly as, now we can say our quadratic expression, which is x squared plus 10x, we shall write plus 10x plus, now the value of c is being replaced by 25. Now it will be 25. And if you factor out, you will find this one, we have completed the square. And if you factor out, you will find this is a perfect quadratic expression. For instance, we can still find the value of c alternatively with another kind of method, whereby we shall say, if we take x squared plus 10x plus c, which we don't know, this is our initial quadratic expression. What is only missing here is c. So if we take that one, it is going to give us the same as we just take another one like x plus, let's say, k, whereby we are going to take it as, it will give you as a perfect square. So if this quadratic expression is required to give us a perfect square, then it means if we take x plus k, it should give us x plus k squared. And if we do that, we are going to find, we are going to have here x squared plus 2xk or 2kx, as you may want to rewrite it. Let me rewrite by 2kx, then plus k squared. So that one should give us x squared plus 10x plus c. Like that. But after writing this way, now we can compare the coefficients of the two equations, and we shall find for the first quadratic expression we have a here being 1, a is 1. If we go to b, you will find that the value of b here is 10, b is equal to 10 here, and the value of b here is equal to 2k. The value of c we don't have, and also the value of k squared we don't have. We need to find the value of k, and if we find the value of k, we shall find that k is our b, but 2k is our b, but we need the value of k. So we can say that 10 is equal to 2k. If you want to find the value of k, then you are going to divide both sides by 2, and you will find the value of k alone is going to be 5. Now we have find k is equal to 5. But here we said our c is represented by k squared, and k is 5. If now you replace that one, we can rewrite this side by saying x squared plus 2 multiplied by k, and k is 5. So if you take 2 multiplied by 5, you will get 10, then you have to that x, and then you add 2, now k, and k is 5. So k squared is going to give us 25. So comparing the coefficient, now you will say that a here is 1 and is also 1. So we are find 10, 10x, but the value of c now will be represented by 25. So c is equal to 25, and our quadratic expression is written in this form. So this is our quadratic expression of x squared plus 10x plus c using completing the square. Quadratic expressions where a is not equal to 1 and is not equal to 0, meaning that a is greater than 1. For this kind of quadratic expression, we shall see how we may find the value of c, and also given the value of c and a, we can find the value of b. For instance, now let's deal with one of the equation and say we have 4x squared minus 12x, and you have been told to complete the quadratic expression by using completing the square method. For instance, now this one, we shall use a different kind of way and say that if we want to find the value of c, now we shall say in general it is, if you take the value of a, which is now here, you multiply by the value of c, which we need to find, you should get b over 2 squared, because here the coefficient a is more than 1. And if we do that way, we are going to get that if we take 4, for instance, what we have here, you multiply by the value of c, which we are required to find, you should get now the value of now b here is represented by negative 12. The coefficient of b is negative 12. Now we shall take that negative 12, divide by 2, then we square. If we do that, we are going to get 4c is equivalent to, if you take negative 12 divided by 2, is going to give you negative 6. So we shall have negative 6 squared. And you will find that our c here, 4c, is going to be negative 6 squared is going to give you 36. If you need the value of c, then you are required to divide both sides by 4. You divide both sides by 4, and you will find that c is equal to 9. Now you can rewrite this quadratic expression in form 4x squared minus 12x. Now this 9 is positive. We didn't find a negative, so it will be plus 9. And we can confidently say that this one is a quadratic expression which has to be found by completing the square, and if you factorize this one, it's going to give you a perfect square. We can use alternative method, which will depend on you which one is best for you, whereby we shall now say we need to find the value of c. But we can first, if you need to find it, first you will do, here you find the square root of this side first. So we shall just find that square root, and you will find is 2x. But we know if we factorize a certain expression, you will find for the ax, you will take to find for ax squared. If you want to factorize, you do find the square root of this one. For instance, here we are going to find the square root of 4x squared, and you are going to get is 2x, and that is what I have right here. And then I shall add to positive what? Positive, I will add to c, which I don't know what is it. So it shall be, let's say no c, let's use another letter. For instance, let's use, for example, p. If we factorize this one, we should get our quadratic expression, which we have in form of 4x squared minus 12x plus c. We are required to find the value of c. But if we need to find the value of c, we shall rewrite this quadratic expression as it is. But we know what is only missing here is c, and that is what we are required to find. So we shall write it with c inclusive. And then we equate this quadratic expression to a perfect square, which will be formed after completing the square, and that is, you find using this method as I show you, and if you find, you will find it is 2x plus a coefficient which we don't know of c, and that is p, then we square. This is a perfect square which has been derived from the quadratic expression here after completing the square. Then let's see what we do find here, and we will find if you square, you're going to get 4x squared, and then the other one is going to give you plus this one by p by 2x by 2, you're going to get 4px. Then the other one here will be p squared. And then this one is equivalent to 4x squared minus 12x plus c. From this part, we need to find the value of p. First, we need to equate the coefficients of each of the a, b, and c. And if we equate the coefficient, we are going to find the first one, the coefficient of a is 4, meaning if we simplify, we are going to get 1, so that one is okay. And the coefficient of here, b here, we are going to get, the first one is 4p, and the other one is negative 12. So meaning we can get the value of p. And if we need the value of p here, we are going to divide both sides by 4. And we shall get that our p is going to be negative 3. If we divide here, we are going to get, it is giving us negative 3. So having p as negative 3 here, we can say, we can find p squared and say that p squared is going to be, now p alone is negative 3. But p squared is going to be negative 3 squared. So you will get our p is 9. And you can now replace this equation by writing. Now, after finding the value of p, now we can write the expression and say that it is 4x squared plus 4p. But we have seen that p alone is negative 3. So if we take negative 3, we multiply by 4, we are going to get negative 12x. But you know, negative multiplied by positive will give you negative. So we shall replace here that one with negative, and we find plus p squared, we find is 9. So this one is the same as this expression, which is 4x squared plus minus 12x plus c. So we can say now the value of c is 9. From the first method, we find if we do that one, we got c to be 9. And here, if using the second method, we are also finding the c to be 9. So we can say now this one is our quadratic expression. And if you factor this one out, you will find two identical perfect squares. And we can say we have factored the quadratic expression 4x squared minus 12x plus c by completing the square, and we have found the result. Now, we can use another method of which we can find the value of b, having been given c and a. For example, we can say now this is my example 3. Having been given, for example, 25x squared plus 9, and you have been told solve the quadratic expression using the completing the square method. For instance, now here, to do what we shall do, we said in order to find AC, a multiplied by c, we said we shall take b over 2, then we square. But here we don't have b. But what we have from this one is relating with the quadratic equation, which is ax squared plus bx plus c. We can clearly say that the value of a here is 25. The value of b we don't know, but the value of c we are being provided with, and it is 9. From this one now we can identify and give out the value of b, and we shall say that b is equivalent to, now a is 25, so we shall take 25, we multiply by c, which is 9, then that one should be equal to b over 2 squared. So if we need to find what is in bracket, then we shall find the square root on both sides. And if we multiply the first 25 by 9, we are going to have 225. So that one should be equal to, if we find the square root of b over 2 squared, we shall remain with the b over 2, because this one will cancel with the square. So find the square root of b over 2 squared is giving us a single unit number, or a single value, which is b over 2. So if you find the square root of 225, you will find the square root is 15. So we can say b over 2 is found by taking the square root of that number, and we have said the square root is 15. So b over 2 is 15. So if we want the value of b here, now we have to multiply both sides by 2 and multiply this side by 2 to eliminate the denominator of b. And if we eliminate, we are going to have b is equal to 15 multiplied by 2 is going to give us 30. Now, we can write the quadratic expression. We can rewrite and say it is 25x squared plus, because b we found to be 30, we can say confidently that it's positive 30. So it will be plus 30x, then plus 9. Now we have solved the quadratic expression 25x squared plus 9 using the completing the square method. And we have found is 25x squared plus 30x plus 9. And we found the value of the missing b is 30. So we have right. You can use the other method to find the value of b, and it will still work. So it's up to you to identify which kind of method is suitable for you. You select it and you work out. The simpler method for you, the better for you to work well. Welcome back. We are going to see how we can solve quadratic equations by completing the square. That gives us our subtopic solution of quadratic expressions, quadratic equations by completing the square. Now here, you shall be provided with different kind of quadratic equations, and you'll be told to solve it using completing square method. And if you use the completing the square, you shall do it using the previous knowledge and how I'm going to teach you. I'm going to guide you through. For instance, having x squared let's take for an example, being given an equation, a quadratic equation of x squared plus 5x squared, 5x plus 3 equals to 0, and you'll be told to solve this quadratic equation using completing the square. Here, what you shall do, if you look at the equation very well, you will identify that it is in the form of ax squared plus bx plus c equals to 0. And if this one has been equated to 0 or to any number, we call that one a quadratic equation. But if this one is missing, like the one which we were dealing with in our previous section, you will identify that if it is missing, it is a quadratic expression. But if this one equal sign is included, then it becomes an equation. For instance, this one here we have been provided with, it is an quadratic equation. So this is an equation, and if we need to solve it now, we need to use the techniques which we used before in solving in factorizing quadratic expression. Now let's go back to our solution here. We have x squared plus 5x plus 3 equals to 0. And we have been told to solve this quadratic equation using completing the square. Now what we shall do here, we shall take 3, here it is positive 3. We need to do something on it so that we may complete the square, though c is present, but we need to make it sure that it is a perfect square. So if that is the case, then what we shall do, we shall first add 5x plus 3, but because this positive 3 is present here, and we need to complete this quadratic equation by completing the square, then we have to subtract 3 on both sides. And if we subtract 3 on both sides, we shall find this one will be eliminated, and we shall remain with the x squared plus 5x is equal to negative 3. And if we do that one, now we have remained with the x squared plus 5x, of which we need now to complete the square on this part. And if we complete this square, we shall find that if we want to find the value of c, where a is equal to 1, we say c is equal to b over 2 squared. And here our b, comparing the coefficient with this quadratic equation, we can find that our b here is 5. Now we have 5 over 2 as our b is, now it is 5, so it will be divided by 2, then we square. So this one here, what we have here is our value of c. So we can write that quadratic equation by x squared plus 5x, which is present, plus now the value of c, which was not present, so plus 5 over 2 square. But because we have added the value of c on the left hand side, to make this equation equal, we have to add the same on the right hand side. That is simply that whatever you do on the left hand side, you also do it on the right hand side, to make that one to be a perfect square. So if that is the case, then we are going to factorize here, and we can find that if we factor out this quadratic expression on the left hand side, you will find it is x plus 5 over 2, then it will be square. If you expand this one, it will give you back this one. So if you factor out this, it's going to give us, that is 25 over 4. So we have negative 3 plus 25 over 4. We are going to get, this one is going to give us 13 over 4. Okay, 13 over 4. So we are finding that one, and it is positive, not negative, so it will remain 13 over 4. So we can see that if we factorize this expression on the left hand side, we shall have it like this, and on the right hand side, if we do the addition and subtraction of the terms which are on the right hand side, we are going to get, first we can do this one is negative 3 plus 25 over 4. And if you do that using LCM, you're going to get, you will find 13 over 4. And if you do that, you equate it to the left hand side, which is x plus 5 over 2 squared. Now, we can find the value of x. And here to find the value of x, we need to find a square root on both sides. You find the square root on the left hand side and also the square root on the right hand side. Such that if we find the square root here, we are going to remain with the x plus 5 over 2 is equal to, now that one will remain square root of 13 over 4, going to give you 1.803 to 1.803 to 4 significant figures. Then if we do that, you will find out that if you find the square root on this side, you will get this one. But on the right hand side, you will get either positive or minus that one. Because it is a square, we may find two answers, one which may be positive, another one negative, or both may be positive or both negative. So it depends. Now, we shall now take this x plus 5 over 2, whereby if we simplify that one, 5 over 2 we are going to get is 2.5, and we can say that this one can be x plus 2.5 is equal to 1.803. So, on working out, we can find that we said x plus 2.5 is equal to 1.803. And on working out, because this one we said it can be either positive or minus, then we can first check taking this one positive, and if we do that, we shall find x is equal to, taking it at positive, we shall find we have to subtract 2.5. And if we take it as negative, then it means our x will be negative 1.803 minus 2.5. And we find different respective answers of x because we had a quadratic equation in form of x squared. So if we do that, we are going to have, for the first case, we are going to have negative 0.697. And for the second case, we are going to have it as negative 4.303. All of these are values of x. Remember, we found our x to have two factors, two identical factors. So we are finding that x is giving us different kind of values because we need each of x and find out what does it represent. So we have worked out and found out that the first x can be used when x is 0.697 and another x when it is negative 4.303. And that one, the way we have solved by including b in each part of the equation, that's where we say we are solving quadratic equation using the square, completing the square. Now we can use it with every kind of expression, equations. That was for numerical. Then we can use it even with the fractions. We may have x squared minus a half x minus a third. For this instance, the same which we applied on the first one, we shall use it on this part. But here, remember, this is fraction. This one has been, the values of the constants, which is b and c, have been represented in fractions. So we shall solve this one also the same procedure as the first one, but the only thing that will be different is the fraction. So here what we shall do, we are going to rewrite x squared minus a half x, but we have this c. So to make it the way we want, so as we introduce the perfect square, then we have to add a third on both sides. So it will be 0 plus a third, you will find a third. And on this side, if you take negative a third, you add positive a third this way, you will find it will be eliminated. So we shall remain with the x squared minus a half x is equal to a third. Now we are missing the value of c. To introduce the value of c here to make it a complete perfect square, then we have to find it. C equals to, since the value of a is equal to 1, then it will be b over 2 squared. So on doing that, we are going to have the value of b is negative a half. But we need to divide it by 2. So if we do that, then we have to square. And if you do this one, you remember, we said it's the same as negative a half multiplied by a half, and then we square. If you remember the way we used to do it in form 2, and you will find out that negative a half multiplied by a half, you will find is negative a quarter, and it is still squared, and that's the value of c. For that case, then we can say this is the value of c. So we can rewrite our equation here now by saying it is x squared, which is here. Then we subtract a half x. Then we add the value of c. But here, the value of c here, we shall have it in bracket as negative a quarter squared, which is equal to, now the right hand side we have a third, but remember we said whatever you do on the left hand side, you also do it on the right hand side. So we are going also to add negative a quarter squared. And if we do that, we are going to get, if we factor out, we shall find we have 1 minus a quarter, x minus a quarter, and then we put it into a bracket and then we square, and we have on the right hand side, if you square this one, you are going to get, this all will give you 1 over 16, because if you square negative, you will find positive. So we are having a third plus 1 over 16 is equal to x minus a quarter squared. So if we do that way, we are going to get, on this part here alone, is giving us 19 over 48. So we are finding that if you find the square root on this side, if we need the value of x, then we are required to find the square root on both sides. And if you find the square root on this side, we shall have the square root of x minus a quarter squared. And if we find the square root on this side, then we have also to find the square root on the right hand side. So we shall find that the square root of x minus a quarter into bracket squared, you will find it as x minus a quarter. But the square root of 19 over 48 is giving us 0.6292 to 4 significant figures. So meaning that a quarter is 0.25. So meaning the value of x can be obtained. And since we found the square root of this 19 over 48, we know that because it was x minus a quarter squared, we might find 2 values. And one, we may consider this square root as positive and another one as negative. So meaning that we may take that answer as either positive or negative. And on doing that, we shall end up with our value of x being x minus 0.25 is equal to, let's consider this answer as positive. So it will be positive 0.6292. Now meaning that our x is going to be, if we go the other way around, you will find it 0.6292 plus 0.25. And this one is going to give you 0.8792. And on the other hand, you may find x minus 0.25 is equal to, now you consider this answer as negative. So if we consider it as negative, you will find it will be now minus 0.6298. And If we consider that way, you will find that the value of x will be negative 0.6298. Is it 92 actually? 92. Now this one on the other side will be positive 0.25. And that one gives you, this one is going to give you negative answer to 4 significant figures. So we have found the two values of x. One is 0.8792 and another one is 0.3792. So we have found two different answers for the value of x after completing the square of that quadratic equation. Now let's look at another example where a is not equal to 1, meaning that a is greater than 1. For that one we can have 4x squared minus 5x minus 4 equals to 0. For this instance now, we shall have to do the same as we did in the previous sections. But remember, for the value of b, I said for where a is not equal to 1, meaning a is greater than 1, then we shall take a multiplied by c. It should give you b over 2 squared. And if we do that, we are going to identify using the quadratic equation, whereby we know quadratic equation resembles ax squared plus bx plus c equals to 0, meaning that here our value of a is 4, value of b is negative 5, and value of c is negative 4 according to this one. But we need to use the completing the square method. So on doing that, we shall now go on and do this way. The first thing, we need to make this left hand side a way to make it in a way that we may add the value of c using completing the square method. Now for this instance we shall take 4x squared minus 5x, but because this one is negative 4, we shall add negative 4 plus 4. On both sides we add 4, and we shall find, if you take 0 plus 4 you will get 4. I haven't done anything, meaning I didn't alter any of this equation, meaning if you take this one back it will always be negative 4. So this one will be eliminated, and you shall remain with the 4x squared minus 5x is equal to 4. Still the same expression, but what only changed is the right hand side are changed to positive 4. So on viewing your left hand side, we can see we don't have the value of c, meaning we have to seek the value of c. Using the previous section knowledge, we can say that to find the value of c, we said we take a multiplied by c and it should give you b over 2 squared. And if you do that, for the value of a comparing the coefficient, you'll find that the value of a is 4, and the value of c here is not present, so we multiply by c, is equal to the value of b, and b is negative 5. So shall be negative 5 over 2, then we square. The value of b here is negative 5. So we say 4c is giving us negative 5 over 2 squared. So meaning that is 25 over 4. If you square negative 5 will give you positive 25, and 2 squared will give you 4. So to get the value of c, you divide both sides by 4, and also this side you divide by 4, or you multiply by a quarter. So if you divide by 4, you are going to get the value of c is equal to 25 by 1, you will get 25, and the denominator is turned into 16. Now we have found the value of c to be 16. We shall rewrite this quadratic equation here, and we rewrite it in a form that we shall have 4x squared minus 5x. Now we include the value of c, but c we have found is 25 over 16. So if we may make it in a way we are squaring, so we shall have positive 5 over 4 squared, but still can be 25 over 16. So that one is going to give us the same as we had on the right hand side, which is 4, but because we have added 25 over 16, which is the same as 5 over 4 squared on the left hand side, we also add on the right hand side. So we are going to add 25 over 16 or 5 over 4 squared. This is just still the same. After reaching that, guys, you have to factorize the left hand side, and on factorizing the left hand side, we said here to factorize, you'll find the square root. You will find it is 2x after finding the square root, and then it will be plus. Now this one I had already found the square root, so it will be 5 over 4. But now this all will be square. And if you do this way, if you do the factorization or the expansion of this expression here will give you back 4x squared minus 5x plus 5 over 4 squared. So, on reaching that one, it should be equal to 4 plus 25 over 16. So, if we need the value of x, we have to work out first. So, this one is going to give us 89 over 16. And this one, if we do out, we will find, if you need the value of x, this first is 2x over 5 over 4 squared. And if you need the value of x, it means we are going to find the square root on both sides. And on finding the square root, we are going to have the other side, the left hand side, we are going to have 2x plus 5 over 4. 5 over 4 is equal to, if we find the square root of 89 over 16, we are going to have positive or minus the square root of 89 over 16. It is 2.89 over 16. So it's going to give us 2 positive or minus 2.3585 to 4 significant, actually to 5 significant figures. So, having that one, we can say the other one can give us something, 5 over 4, and that is 1.25. So, we can write and say 2x plus 1.25 is equal to positive or minus 2.3585. So, having that one, we can find the value of x and say 2x is equal to, if we take this right hand side first to be positive, then we shall have 2.3585 minus 1.25, and we shall get 2x is equivalent to 1.1085. And if you do that way, you are going to have your value of x as, you divide both sides by 2, and you will have the value of x giving you 0.5543 to 4 significant figures, or to 4 decimal places. So we are going to have the first x as that one. And if we consider this answer here as negative, we are going to have another answer for x. We shall have another value for x. For instance, having 2x plus 1.25 is equal to, here we have 2.3585. We have said we consider it as negative. So considering it as negative, we are going to have another kind of an answer, and we shall have 2x, but this one on crossing the equal sign will be negative 2.3585 minus 1.25. And on doing that, we are going to have 2x is equal to, I'm going to give you negative 3.6085. Guys, having that one, we can still find the value of x by dividing both sides by 2. And on dividing by 2, you are going to have your answer as negative 1.8043 to 4 decimal places. So we have found two values of x, and the first value we found is positive, and the second value is negative. So with that, we have come to an end of solution of quadratic equation by completing the square, and we have seen how to find the equations and the values of x using completing the square method. And we have seen, in case we have a as 1, for both cases, you can find the quadratic equation of any given quadratic equation using that completing square method, for where a equals to 1 and a is not equal to 1, for both fractions and also real numbers, numeral numbers, the way you may be given. We shall see how we may find quadratic formula in our next session, and how we may use that quadratic formula to solve quadratic equations. We are going to see how we can derive quadratic formula from a quadratic equation. From our previous session, we saw how we can solve a quadratic equation using completing square method. Now we are going to use the same equation, which was ax squared plus bx plus c equals to 0 as the general quadratic equation, and see how we may derive quadratic formula from this general equation, and how we can use that quadratic formula to solve different quadratic equations. For instance, being given this one, first of all, we need to solve it in the way we used to solve it using completing square method. And for that instance, we say we shall take ax squared plus bx plus, now on the left hand side, whatever we do, we need to do it on the right hand side. And we did say if this one is positive, we have to subtract the same identity, which is negative c, and then on the right hand side, we also do the same, so as to have ax squared plus bx plus, now plus c minus c will cancel itself out, and we shall have 0. So meaning the value of c will not be present. So we are going to get negative c. For that case, we need to find the value of c on the left hand side, meaning we have to complete the expression of the left hand side to make it a perfect square expression. And now before that, we need to divide both sides by a, so as to make the value of a in x squared to be equal to 1. The coefficient a, we have to minimize it so that it may be equivalent to 1. So if we do that, we shall find this one will cancel out, and we shall make the x squared plus b over ax is equal to negative c over a. After approaching to that part, then our next thing, we shall make the left hand side be a complete perfect square. And on doing that, we are going to introduce c. And we did say if a is equal to 1, to find the value of c, we say we take b over 2 squared. Remember, using the completing square method. And if we do that, we know the value of c, we shall find it by b over 2 squared. But now our b is equal to b over a. The coefficient of b here in this quadratic equation we have formed here, it is equal to b over a. So we are going to have b over a, this is c, but this one is over 2. So meaning if it is over 2, it's the same as putting that 2 there. So we shall have b over 2, c is equals to b over a, but we are dividing by 2, meaning it's the same as times a half. Dividing by 2 is the same times the reciprocal of what we are dividing with. So means we are going to multiply by a half. But this one we are going to square. And on doing that, we shall find we have b over 2a, but we are going to square. And that is the value of our c. So meaning, if we do that, we are going to find c as b squared will give us b squared, and 2a squared, we are going to have 2 squared first will give you 4, and a squared is going to give you a squared. So that is what we are ending up as the value of c. So in this quadratic equation we have here, we need to make the left hand side to be a complete perfect square. And on doing that, we are going to have x squared plus b over ax plus the value of c, and c here we have found it to be b squared over 4a squared, of which if we may factor it out, we shall find, putting the square, we shall have this one which we have, b over 2a squared. Or you can still write this one, it's still the same. And since we have added c on the left hand side, but we have said whatever we do on the left hand side, we also need to do it on the right hand side. So we have added b over 2a squared on the left hand side, and that means on the right hand side we also add that b over 2a squared. Or still you can write this one, still will give you the same result. So doing that, then we can now factor out the left hand side, and we shall have, here we shall find x minus now this one which is b over 2a squared, because we are factoring out, meaning that if you do this one, this is plus actually, if you do expand this expression here on the left hand side, you still find the same expression as we have here. And if you do that, you should get negative c over a plus b. Now if you do it the other way, you will find it is b squared over 4a squared. Now that's what we are getting there. And on doing that, let's first deal with the right hand side. And dealing with the right hand side, we are going to have negative, first the LCM of the two numbers is 4a squared. And if you do that one, you will get, this one is going to give you 4ac, because a into 4ac, a squared, you will get 4a. If you multiply by c, it's going to give you negative 4ac. Now, we have to add this sign, and then this one into this one will get 1, and this one will remain b squared. So we have gotten that if we rewrite this one starting with the positive one, we are going to get b squared minus 4ac over 4a squared. That's what we are getting at that point. So, having that one, then we can say that this, what we have here, is equal to that one. So, let's see how we can solve that. X plus b over 2a squared is equal to, now we have b squared minus 4ac over 4a squared. Now we need to find the value of x. And finding the value of x means we find the square root of this side, and we also find the square root of the right hand side. Doing that, we shall remain with the x plus b over 2a on the left hand side is equal to the square root of b squared minus 4ac over 4a. That's what we are going to get, over 4a squared actually, because that is what we have in the numerator. So after doing that, we can now get the value of, if you find, first of all, if you find the square root of this one, it will give you either positive or negative. So if you need the value of x, you will transfer this one to the other side. X is equal to, you will transfer, and it will become negative if it crosses the equal sign, and you will have the square, the answer under the square root sign, you shall find it to be either positive or negative. And on doing that, we are going to have b squared minus 4ac over 4a squared as the answer under the square root sign with either positive or negative sign, then we shall be subtracting minus b over 2a. Now, after getting that one, we can still simplify it out further. We can simplify it further by saying this one will always remain either positive or negative under the square root sign. So, if we simplify it the same as writing that one will give us x, the value of x is equal to, so the value of x to find it is equal to, the answer under the square root sign will be either positive or minus, and then the square root sign, now we are making it to be much more perfect and possible, which is b squared minus 4ac over the square root of 4a squared. And if we do that, we are going to get, this one will be, after getting the answer of this one, we are going to subtract b over 2a. And if you do that, you are going to have your answers. If you find the square root of 4a squared, you will find it to be 2a. So we are going to have the square root of positive or minus the square root of b squared minus 4ac under the square root over 2a minus b over 2a. Now, we need to make the LCM to be equal. And if we do that, we are going to have 2a and 2a, the LCM is 2a. So we shall have 2a on the denominator. And if we do that, you will find this one goes there once. And if you multiply with the upper part, you will find it is either positive or minus the square root of b squared minus 4ac. But the other one also goes once, so it will give you minus b. And if you do that way, we are going to get what we have there. So doing that one, we can say the value of x, starting with the one which is possible well written, so it will be negative b plus or minus square root of b squared minus 4ac over 2a. And with that, I will say that is the formula for the quadratic formula which we have derived, and we can use it to solve any quadratic equation. From our general quadratic equation, we have seen how we have derived and found the quadratic formula. Now we shall use this quadratic formula to solve different kind of quadratic equations. For instance, being provided with 7x, let's say, is 4x squared plus 7x plus 3 equals to 0. If we check at this quadratic equation, we find that it is resembling our general quadratic equation, which is ax squared plus bx plus c equals to 0. And from this, we can identify the coefficient of a in our example as 4, b, whereby b is resembling with the coefficient 7, and c we have 3. Now we can use our quadratic formula to find the value of x, the variable x in this section, and we shall say to find the value of x, relating using the quadratic formula, we have negative b, but here b is positive 7. If it could be negative, then we could say we should take negative and insert it here or substitute in value of b, and we shall find negative 7, and that could be positive. But for this case, this b is positive 7. Therefore, if we replace, it shall remain negative 7 plus or minus the answer under the square root sign, which is b squared, and b squared is 7 squared minus 4 multiplied by a, and we have said a is 4 multiplied by c, and c is 3 over 2 multiplied by a, and a is 4. So if we do that way, we are going to find negative 7 plus or minus the answer under the square root sign, and we can find 7 squared is giving us 49, minus this 4 by 4, 16 by 3, this is actually 3, by 3 we are going to get is 48. 2 by 4 we have 8, and if we do that we are going to get negative 7 plus or minus the answer under the square root sign, and the answer under the square root sign is 49 minus 48, we are going to get positive 1. If we find the square root of positive 1, we are going to get is 1. Therefore, it shall be over 8. So, for that case, we can say if we need x1, we shall find that x1, or the answer for the first variable x, it will be, we consider the answer under the square root sign to be positive. And with that case, we shall say it is positive 1. So, we divide by 8 and we shall get this one is negative 6 over 8, which is giving us negative 3 over 4. The second value of x will be derived by considering the answer under the square root sign to be negative. For instance, if we consider it to be negative, then it shall be negative 7 minus 1 over 8. And we shall find is negative 8 over 8. And this one is going to give us negative 1. So meaning, we have two different values of x. As per quadratic equation was squared, so we are getting two values of x. Therefore, we have x1 equals to negative 3 over 4, and the other one equals to negative 1. We have seen how we can solve using any kind of quadratic equation, be it of fraction or be it of any kind, where x equals to a equals to 1 or not equal to 1. You can use this formula to solve any kind of quadratic equation for it if it works. Let's see how we can form quadratic equations. And the information of quadratic equation is whereby you are being given some different kind of solutions for problems, and you require to find the solution to these problems. You may use quadratic way of solving it and find out the solution for the problems. For instance, having a problem like this, for example, a 2-digit number is such that the product of its digit is 12. When the digits are reversed, the new number formed exceeds the original number by 9. Find the original number. And from our kind of knowledge, we know that a 2-digit number is a number like 99, 88, or 17, or even 33 is a 2-digit number. And from the observation, we can say that this number is formed by a tens number, which is like digit 9 or 8, 1 or 3, then followed by ones, the one which is in ones number, as we were learning how to write those numbers. So, considering this, we can say if you need to find this 99, you will take 90, which is the same as 10 multiplied by 9, then we add to 9, which is in ones. This is what we are referring to. If you do that, we are going to get 99. Taking an example, this one was xy as our 2-digit number, then it means it's the same as taking 10 multiplied by x, then we add it to y, meaning we shall get 10x plus y as a 2-digit number from this observation. Now we can solve our problem here. We are ready to solve the problem, whereby we were told a 2-digit number is such that the product of those 2-digit number is 12. And we have seen if the number, let the number be xy, for example, the 2-digit number to be xy, in that case, then it means that this number, if we take the digit, that is x multiplied by y, which is xy now, this is a multiplication of the number. If we take x multiplied by y, we should get 12, meaning that xy equal to 12. But if the digits of the number are reversed, the new number formed exceeds the original number by 9. So meaning that initially we have seen that the original number being like this, the original number will be 10x plus y. For the case, remember for the case of 99 how we have done. And if it's this way, if we reverse the digit, then it will become to be the new number. This was the original. But the new number formed will now be reversed in such a way that it will be 10y plus x. And we have been told that this new number formed exceeds the original by 9. Meaning that if you take this new number, subtract the original number, you should get 9. Let's see. That if you take 10y minus 10y plus x minus 10x plus y, you should get 9. And remember here we had the product of the two digits, you get 12. So if we do that, we are going to get 10y plus x minus, now if you open the bracket here, you are going to get 10y minus y, you will get 9y. And positive x minus 10x, you are going to get minus 9y. So this one is equal to 9. Actually, it's 9x actually. Sorry for that inconvenience. So x minus 10x, you are going to get 9x. So that is what we are obtaining there. We can still find for, here we have xy equals to 12. So meaning we can use it, xy equals to 12. We can make one of them the subject. And if we make one of them the subject, we can use this one to make one of them the subject, in that we can find 9y minus 9x equals to 9. So let's make x the subject. So we shall say, let's use this one. So if we use that one, we are going to have, let's say 9y is equal to 9. Now this one, because it's negative, let it be the other way, and it will be plus 9x. Now to find the value of y, we need to divide both sides by 9. And we find y is equal to 9 plus 9x over 9. Now I made y the subject, so I'm going to replace it in the new equation. Or you can even use this one. The way you think is simpler, the better for you. Now we are going to replace it here, and we shall find, for the value of y, I'm going to replace it with 9 plus 9x over 9 is equal to 12. If I do that way, then I'm going to open the bracket, and I will find 9x plus 9x squared over 9 is equal to 12. I want to eliminate the denominator on this side, so I'm going to multiply both sides by 9. So if I do that way, I'm going to remain with the 9x plus 9x squared is equal to 12 by 9. What do you obtain? You get 108. You get 108. So we have formed a quadratic equation by the form 9x squared plus 9x equals to 108. You can use this one by putting the other way around. You find 9x squared plus 9x minus 108 equals to 0. If you use the other kind of quadratic equation method. So here we can see that 9 is common in both of them. So we can still divide out and find out that x squared plus x plus 12, and now it will be minus 12 is equals to 0. 0 divided by 9, and we are going, for this case, we shall find 0 at this level. So having that one, we have seen this one, we have found a quadratic equation, and we can now use quadratic formula or complete square method to find the value of x. For this case, even we can use a similar way by factorizing, which we learned in form 2, whereby we can now factorize x squared plus 4x minus 3x minus 12 equals to 0. I'm using the way of factorization to solve, and if I do that one, I'm going to get x into x plus 4 minus 3 into x plus 4 equals to 0. Now if I do that way, I'm going to take x minus 3, x plus 4 equals to 0. Now I will let 8 of the bracket to be equal to 0. Still, you can use the formula of completing square and you will find the same answer, and you can use even the quadratic formula and you will find the same answer as what I am going to get. Now, I will equate one of the bracket to 0 and I will get x minus 3, for example, is equals to 0, one of the bracket, meaning that either this bracket is equal to 0 or this one is equal to 0. So if I do that way, I will get x is equals to positive 3. If I equate the second bracket to 0, I will get x plus 4 is equal to 0 and I will get x equals to negative 4. But since it is a real number, then it will not be a negative for this case because we are talking about a number. And that number is a number such that when it is combined with another number, it will give us 1 in tens and another one in ones. So we cannot take or consider x as negative 4. So our x will be positive 3. And from the equation where we said the product of the two-digit number is equal to 12, then we can say that if we replace x with 3, and then y, we shall get 12. And if you divide, you are going to get y as 4. So meaning, the number formed, we had first, we said the original number was 10x plus y. The new number formed, this was the original or the old number. Now the new number, let me make this much more well visible. Old number, we found it to be 10x plus y, and new one was 10y plus x. Now, if we replace that values, for example, x is 3, so replace here by 3, you are going to get this one will be 30, and y is 4 for this case. And if replace, you will get 30 plus 4, you are going to get 34. And here you will get, here is 4, here is 3, and you are going to get is 43. If you take 43, the new number, subtract the old number, you are going to get 9. And that proves that our quadratic equation gave us the right way to handle this quadratic equation. So we have seen that problem can be handled that way. More problem may come in form of linear motion. Others may come in different kind of equations. For example, we shall handle another second example. We shall handle example 2. And this is an example whereby most students fail to identify which kind of a problem it is. So we have been provided that a bus and a matatu are traveling from Nairobi to Nakuru, a distance of 280 kilometers away. A matatu maintains a speed of 20 kilometers per hour than the bus and arrives 1 hour 36 minutes earlier. Find the speed of each vehicle. So most knows that this one is a linear motion equation, failing to identify that it's a quadratic equation. And from the way it looks, you will identify that having been provided with the distance here, we can still form a quadratic equation by saying that we know that if you need to find the speed of any given object, we do take distance, the distance covered, we divide it by time. Since these two vehicles, which is bus and matatu, are traveling from Nairobi to Nakuru, we can say the final destination is Nakuru and the initial departure time and the departure place is Nairobi. And distance in between them is 280. So meaning that is the distance to be covered. So here we shall be taking distance to be 280 kilometers. But the time we haven't been given, but we have been just given an information that the matatu arrived 1 hour 36 minutes earlier than the bus. So we can do that one still by forming a quadratic equation, and we shall say, since we have been told a bus and a matatu traveling from Nairobi to Nakuru, a distance of 280 kilometers, so we shall say, let the speed of the bus be x. Let the speed of the bus, now we are dealing with the bus and matatu. So let the speed of the bus be equal to x. And that of the matatu now will be, if the matatu maintains a speed of 20 kilometers per hour faster than the bus, so meaning this one will be, the matatu will be going at x plus 20 kilometers per hour more than the bus. That is the speed of the matatu, and this is the speed of the bus. Now the time that the bus will take now will be the total distance covered over the speed of that bus, and for the matatu it will be 280 over x plus 20 kilometers per hour. From this section, now we can form a quadratic equation by saying that we know if this one moves faster than the bus, then this one will take lesser time compared to the bus. So meaning that if we take the time the bus takes, which is 208 over x, we subtract that time that the matatu takes, kilometers per hour, let's just take that way, we should get, we have been told it arrived 1 hour 36 minutes earlier. So meaning we should get 1 hour 36 minutes earlier. So that is 1 hour 36 over 60. And if we simplify here, we are going to get here 6, here 10, and then if we do the other way, 3. Actually it's 3 over 5. That is 3 over 5. So in improper fraction, we are going to get 8 over 5. So having that, we can still say, if we do that one, we are going to have LCM very long, but we shall use it. So it means the LCM, it will be x, the first x plus 20, and then 5. I'm just using the whole of the denominator so as to make the LCM be simpler to find. So if that's the case, then x will go into this kind of LCM. Now this one will cancel out, and I remain with this. So I'm going to take 208, which is on numerator, and then I multiply by 5 by x, I will get 5x, plus 5 by 20, I will get 100. So then the sign minus, and then this one, which is 280 over x now, x plus 20 into this LCM, I will get 5x, so it will be 5x, and then it will be equal to, since I have done that way, still the LCM will be the same, that is x plus 20, and then 5. So doing that one, we will find that one will cancel this one, and we shall remain with the 8 on the numerator, and then we are multiplying with what we shall find. Since 5 cancels 5, we shall have x squared, and then x by 20, so it will be 20x. Now, we can remove the denominator by multiplying both sides by x. This the denominator, we multiply by that denominator. We shall find this one will cancel with this on both sides. Cancels the other. So we are remaining with the 280 multiplied by 5. And we shall find this one is giving us 1400 x plus 228,000 minus 1400x is equal to 8x squared plus 160x. That's what we can find from that equation. And if we do that way, you will find this one is positive, this one is negative, meaning it will cancel each other. And we are going to remain with it. 28,000 is equal to 8x squared plus 160x. Now 8 is common in both of them, so we divide by 8, both sides. So we are going to remain with it. X squared plus 20x is equal to, now 28,000 divided by 8, you shall get 3,500. So that's what we have found, and that is what we call our quadratic equation. So from that given problem, we have found quadratic equation which we shall use it to solve the value of the x, and that x represents the speed of the bus, and from that we can still identify the speed of the matatu. Now from that equation we have x squared plus 20x equals to 3,500. We can still make it to be x squared plus 20x minus 3,500 equals to 0. Now we can identify two numbers, whereby if you multiply it will give you, the product of those two numbers is going to give us negative 3,500, and the sum of those two numbers will give us positive 20, the value of b. Now from that one we can identify the numbers as, we are going to identify the two numbers as 70 positive and negative 50. Now from that we can say, we write the value of b with the two numbers with the variable x, and say it is x squared plus 70x minus 50x, the two numbers to replace the value of b here. And if you do this one, you are still going to get the value of b, which is positive 20x, then minus 3,500 is equals to 0. Now we are going to factor out the value of the term which is common in both the factors. So we are identifying the first two factors, and we find it's x. So if I factor out x, I'm going to get x plus 70 minus, then if the two factors here, the one which is common is 50. Now because it's negative 50, this one will give me positive x, and the other one will be positive 70 is equal to 0. Since the two terms in the bracket are equal, then I will take the one which are outside and factor them together into one bracket, such that I'll get x minus 50, and the one which are outside. Then after doing that, we shall find that if you factor out the outside bracket, you are going to get x minus 50, and that is this, and the one which is in the bracket, you are going to get x plus 70 equals to 0. Then we shall equate one of the bracket to 0, that is x minus 50, for example, is equals to 0, and have our x as 50 kilometers per hour, because it was a speed. And if we equate the next bracket, which is x plus 70, we shall find that our x is going to give us negative 70 kilometers per hour. But as we know, it is only negative if it is depreciating or accelerating. But this one is a speed which they are moving on, so the speed should be positive. And if it is positive, then it means that our value for x, it will be 50 kilometers per hour. So from the equation we saw that the speed of the bus was x, but that of the matatu was x plus 20. So we can say from that we have created that we found x equals to 50 kilometers per hour, meaning that of the matatu will be x plus 20, so it is 50 plus 20, and we shall get is 70 kilometers per hour. So we have found the speed of the matatu and the speed of the bus. We can prove, and you will find out that if you take 280 kilometers, then you divide by the speed, which is 50 minus 280 divided by the speed of the matatu, which is 70, you should get, let's see, it should give us 1 hour, which is 36 minutes, which is 3 over 5, or this one should be 8 over 5. Let's see what we get here. And this one is going to give us 5, 3 over 5. So if you get 5, 3 over 5 minus 4, you are going to remain with 1, 3 over 5. And we have seen the two are equivalent. So meaning that whatever we have found is the correct answer. And that is how you can solve any kind of given problem if it relates with the quadratic equations. We shall see how we may form a quadratic function on a graph, meaning we shall be handling our next session as graph of quadratic equations. In our previous section, we learned how to find the solutions to quadratic equations. And now we are going to see how we can find or draw graphs of quadratic function given different kind of quadratic equation or functions. Now, I remember in our previous session we learned about how we can draw a graph of y equals to mx plus c, meaning it's a linear function. And we saw that for every kind of x, we found a corresponding value of y. So today we are going to see how we may find the quadratic function and see how those functions relate with each other from the way we shall be drawing them on a graph. For instance, we have some different kind of graphs. This one is a quadratic function, and we can say y equals to x squared is a quadratic function. When drawn to a graph, it will give you a different kind of a graph. And we shall also witness if we draw it together with another kind of a graph, which is y equals to negative x squared, and we shall see the relationship between the two types of quadratic functions. For instance, let's see for the value of y equals to x squared, for example, given that we are drawing y equals to x squared from negative 4 to positive 4. Let's see if the values of x varies from negative 4 to positive 4. Let's see what can we find for the value of y. For example, if it's negative 4, we shall have 16. And for the other one, we are going to have, this is a graph of, this is y equals to x squared. Now I want to draw that of y equals to, this is the table for y equals to x squared. Now I want to draw that of y equals to negative x squared. And we shall find it has kind of different values from that one. We can find for every value of x, we are getting a negative value of corresponding y. So we can draw the two graphs, for instance. Let's take a Cartesian plane here. I'm going to draw them here. Now, having that kind of graph, Cartesian plane, we can now draw a certain graphs of those two corresponding functions, quadratic functions. For instance, having for the first one, we say we are going to see graphical solution of quadratic functions, quadratic equations, and from this one we may be provided with different kind of quadratic equation. For instance, having this x squared minus x minus 6 equals to 0, you can draw out the table for x and y, and you find out where there is 0, you replace with the y, and then you find out the values of x and also the values of corresponding y. Then on drawing the graph, you are finding the graph looks or seems to be aligned with my graph here. So this is the graph whereby the line is y equals to x squared minus 6 minus x minus 6. So on that graph, we can identify this kind of conclusion that on the value of the curve here, we are finding that the curve cuts x-axis at 2 distinctive points. So meaning we have 2 different kind of points where the curve cuts the x-axis. Actually, we can identify it cuts x-axis at -2 and also at +3. So from that way, we can say that where the first cut is, it cuts at x equals to -2, and the second cut it is at x equals to +3. And we can conclude that the points where the curve of a quadratic function cuts the x-axis, at that point is where we refer to as the roots of that curve. For instance, if it is an equation of a quadratic function, then the x or the points where that quadratic function cuts the x-axis, that is the point where we call the roots of that quadratic function. For instance, the roots of x squared minus x minus 6 equals to 0 are -2 and +3. So we can conclude that from our graph, -2 and +3 are the roots of the curve which we have drawn. And if you have been given any kind of a quadratic function and you find that that function or that equation cuts the x-axis at a given point, if it cuts at 2 distinctive points and is a quadratic function, then that 2 distinctive points are the roots of that quadratic function. And if you may draw your curve and you find if this is the x-axis and this is y-axis, and you find that your graph comes but it only touches the x-axis, maybe at 0, x equals to 0, or at even this point, the graph may even touch at this point where x may be equals to 2 or even 4. The point where it only touches, it may be from downward part and then touches only the x-axis and then goes back. Maybe this is x equals to 6. If it touches the x-axis only once, then it means it has a repeated root. And that repeated root, its solution is equal to that point where it cuts the x-axis. For instance, at this point, then for this graph, of which it may be y equals to x squared, its solution is x equals to 0. And for the other graph, which we don't know what it may resemble, it cuts at x equals to 4, then that one is the possible solution for the graph. And remember, we have said it is a repeated root. And if you may find that your graph, you have drawn a graph or a quadratic function, and you find out that it doesn't cut x-axis at any instant point. It may be that way, or even the graph may come from downward path and then goes back. It doesn't cut x-axis at any given point. Then that graphs have no real roots. That is what we are saying. If you use that quadratic formula to solve that kind of quadratic equation, you will find that b minus, or the answer under the square root sign, is less than 0 or below 0. So that one has no real roots. We shall see how we shall solve a simultaneous equation using graphical methods in our next session. Thank you. Welcome back. We are going to see in this section the graphical solution of simultaneous equation you may be given two kind of equation, in that you may be given a quadratic equation and a linear function such that y equals to mx plus c, and another one a quadratic equation, and it be put together and you find the value of x for the two, or where the two cuts each other. And another way, you may be given two quadratic functions and you be told to find the solution to the two quadratic function at the point where they intersect. You give out at that point. Now we are going to start with that of a quadratic function versus a linear function. Let's see how it works. So having our example as the y equals to x squared minus 2x plus 1 and y equals to 5 minus 2x within an interval of x equals to negative 2 to 3. This is interval of negative 2 less than or equal to x less than or equal to 3. So having that interval, we can see the first given expression here is a quadratic equation, and the second one is a linear function, or linear, it's a linear function actually. So the table for the first quadratic equation on drawing, you will find the table looks like this. You may try to enclose it as you wish. It depends with your own. So that's the table for that, and then for the linear function, you find the table is this. And on drawing it on a graph, you will find this last stage, but on drawing it, you will find that the graph of the quadratic function, you will find it is turning, but it turns on the 1, x equals to 1. So it turns at that point, that is the minimum point of the graph. And then on turning, we find that if we draw that line or the linear function y equals to 5 minus 2x, we are going to get, it passes and cuts the graph at two distinctive points. That is the first point here, and the other point where we obtain is that point. So we are finding it cuts the graph into at two distinctive points, and that is at point negative 2, 9, and also at point 2, 1. That is the point where the linear function, which is y equals to 5 minus 2x, cuts the quadratic function y equals to x squared minus 2x plus 1. So we can say that the solution for this quadratic function and the linear function, we can say the solution is x equals to negative 2, and that the other x is equal to 2. The solution is this one. So you can give the points at where it cuts, where x equals to negative 2 at this point, and also at x equals to 2. But the points at which it cuts is negative 2 and 9, and 2 and 1. You can give the two as identical as we have found from the graph. That same knowledge can be used to handle any kind of given quadratic function together with a linear function. You can use it to handle any kind of given quadratic function and still solve and get where you can get the value of x and also the value of y at that point where the linear function cuts the quadratic function on the Cartesian plane. So given this kind of quadratic equation, you are being told using this one solve the other quadratic equation, and from this, if you have been given y equals to x squared plus 3x plus 1, if you want it to solve the other kind of equation, now you will put the other way, and then you say let's start with this one as number 1 and this one number 2. Then from these two, you will say y equals to x squared plus 3x plus 1. And then here we have to solve this part to remain as 0, whereby we shall bring this 6 to the other side by subtracting 6 on both sides. And we shall find for this equation, we will have, if we subtract 6 from this side, we shall remain with 0. And if we subtract from this side, we shall find here is positive 2 minus 6, you will get minus 4. So we are going to have x squared plus 3x minus 4. So on doing that, we can still solve this quadratic formula by just eliminating it by subtracting here, whereby -1, that is +1 minus 4, you are going to get -4 or negative -4, you will find it is, now it will give you +5. And then 3x minus 3x, you are going to get here is 0. And x squared minus x squared, you will get 0. And here y equals to that one. So we are going to find that y equals to 5. So that's the first of this number 1. For the second one, for this second one, we are just going to do the same. That is y equals to x squared plus 3x plus 1. Then we take this one, starting with the other part, which is 0, is equal to, now there is all of the quadratic equation, x squared plus 2x minus 2. Then we do subtract again. You will find 1 minus 2, you are going to get +3. And then 3x minus 2x, you will get x. And then x squared minus x squared, you will get 0. So y will remain, y minus 0, you will get y. And you are going to get y equals to 0. Let's just write it in full. That is y equals to x plus 3. So we have found this the second. This was the first. Now we can rewrite them up here. We want to solve them. We are going to solve first for y equals to 5, and second now y equals to x plus 3. That is what we have found. We have just changed the quadratic equation into linear functions. And then we use that quadratic equation which we have been provided with on the graph, and we find the values of those ones. So let's form the table for y equals to x squared plus 3x plus 1. The quadratic equation which we were provided with, and we found that the first one was equivalent to y equals to 5, and the second one y equals to x plus 3. Now we have formed some tables for the given equations. That is for the quadratic equation y equals to x squared plus 3x plus 1, we have found the table is like this. And for the second one, for the linear function y equals to x plus 3, we have found the table is in this process. So if we draw the graphs of y equals to 5, y equals to x plus 3, and this one on the same Cartesian plane, we are going to find the graphs are identical as we have seen here. Y equals to 5 is a straight line running parallel to x-axis and run through y equals to 5 at this point, and then it is parallel to x-axis. So it casts the graph at this distinctive point. We can obtain that point, and also, actually it's not that point, but the other way here. So we are finding that for the first one, we can give out the point where the y equals to 5 cuts the curve y equals to x squared plus 3x plus 1. We see it cuts it at x equals to -4, and also at x equals to, that is +1. So we can give that for this one, the solutions are x equals to -4 and x equals to 1. As you have seen, we have already solved that one. So for the given graph, the given quadratic equation, which was x squared plus 3x plus 2 equals to 6, we have seen the solution is x equals to -4 and x equals to 1. For the second one, now for that x squared plus 2x minus 2 equals to 0, whereby we found is resembling a linear function x plus 3, we have seen it cuts the graph at this section here, whereby the section is in between, is not 3 and is not 2, but it is close to 3. So we can approximately say this one is approximately, because it is too close to this, we can say it's 2.7 or 2.8. But if you use the graph very well, you will find out that this point, it will give you a definitely correct answer. But for mine, it's approximately to 2.8. Approximately to 2.8. And at this point here, I'm finding it's almost approximate to 1, but it's not 1. At this point, I'm getting it to be 0. Now this one will give me 0.8. So I'm finding out that for this one, x equals at negative 2.8. At this point is negative, so negative 2.8, and also x equals to 0.8. So meaning that for the quadratic equation x squared plus 2x minus 2 equals to 0, we have the solution as x equals to negative 2.8 and x equals to 0.8 as per my graph here. If you draw it well to scale, you will find out what the real value represents as, and is equivalent and much more close to what we have seen here. So, given any kind of quadratic equation, and you'll be told to find out the kind of solution to any kind of quadratic equation, you just draw the graph of the quadratic equation which the reference has to be made, and then from drawing that one, you now use the relation by the way I have handled the others, and then you plot them on the same Cartesian plane and you identify the point where they cut each other. By doing so, you will have find at that point where they cut each other, or the curve which is the reference point, then that's the solution to each of the given quadratic equation. Okay. With this graphical solution of simultaneous equation, we have come to the end of the first topic of Form 3, and we have seen how we have handled the topic, and I think it has been interesting.